I actually tried to record a couple clips, but I just kind of been rambling, and then I'm gonna realize I'm gonna have to like edit the crap out of them or whatever. And I just said, you know, screw it, I'm just gonna make a live video. So got the Goodman unit hollering over there, so hopefully you guys can hear me okay. Nobody's. Oh, upstairs unit just shut off. But anyway, so what has it been, a month almost since I had the tragedy here? This is the tall 3-ton heat pump. I wanted to, just for people that haven't followed the videos, these were like units that had some sort of issue or something. I got them for the cabinets, okay, to make slender heat pumps in place of my 2 units over there, because I'm going to open this up a little wider for backing my trailer through. Right now when I bring my trailer home, take the Can-Am off, put it in the garage, and I have to push the trailer through here, and it just barely almost scrapes the AC units getting in here. I gotta fix that block wall over there. I'm gonna do that. So this is the unit first unit of 2 alike I got. I was making my own VFD controller for a regular scroll 2-speed. All that worked, my controller work that I made. Circuit board I etched. I spent all that time kind of crafting my skill on that router and everything in there. Kind of spliced some wires and I was testing this thing here. But anyway, when I tested it in the garage, as you guys saw, it worked. The VFD DC bus was powering the inverter board that I left in here that was powering these 2 fans. And I used my own pulse width modulated signal from here to a adapter board I made to control the speed of the fans. It all worked in the garage. It worked perfect. I come outside, plug it in, or actually I piped it into my house in place of the Lennox unit, and I hook up the high voltage, you know, in, goes to the VFD. VFD's DC goes through this board I made. It was just an adapter board for the wiring harness into this inverter board, and boom, you could see the lava that's left here. It was just blowing up the trace. It just looks like a lot, but I blew up both boards I made. I had like 2 boards made. I'm like, boom, what the hell? I'm like, why? What's shorted? Anyway, I kind of put this off. I was like, you know what, summer's starting, you know, probably not the best thing to like have issues on my upstairs AC, which is where most everybody except for the daughters, the one daughter, we all sleep upstairs. Can't have that. So put this off. Maybe I won't do it to this. I don't know if I'll put different motors in it. I'm like, what the hell? I'll just put this off to the side. So I've got some other AC units. I have that one back here I'm still going to test. I got my hands on this 1.5 tonner. I was messing around, so I stuck a high wall on it that I had with and I had the remotes. It actually turned on and kind of worked, but then it would shut off on a P4 fault. The unit's about 2 years old. It was changed out because somebody couldn't figure out the issue. I really wanted it for the cabinet, which I just have all the panels off. It's actually complete. The reason I wanted this is because I actually want to take that heat pump that's ugly, that's been heating my water for 2 years now just fine. For people who haven't seen it before. Actually, I meant to turn off my Goodman unit. That should stop in a second. This is the heat pump. It's running right now, so it blows cold air just outside. And this was a wine cellar condenser unit. I took a rotary, 410 rotary off of one of those portable AC somebody gave me. I turned this into a dual circuit evaporator, used capillary tubes. That found some chart to see what length at that diameter for the BTUs of each half, and it actually worked. The pressures are fine. Never had an issue with it. Actually, that's just one of those Frankensteins that just worked the first time, and it's worked for 2 years now. This is running off of an inverter inside that charges the batteries off of the off-grid sun in the back. But now that when I repurpose this, all the cold air just blows outside during the summer. It could be blowing inside. So I don't know, I'm kind of thinking of redoing it. So I want this cabinet to probably just put that compressor in, split up the coil in a couple halves or whatever, because it doesn't need to be that big. And but I want to make it dual mode so it can. I'm going to take that high wall I took to the Frederick and probably get the Frederick out of here because it's too big. You know, when I want to get the trailer through here, I want to widen this. Take the line sets from that high wall and plug it into that. It'll switch on when it heats the water, but then it'll blow cold air in there. That'd be awesome. And then what I want to do is make it in the summer when I want to go in there in the afternoon and the sun's up. This thing can run right off the sun. I want to have it to where I can switch, you know, or turn it on demand for cooling the garage, or at least where I'm sitting. It won't cool the whole garage. Hey, what's up, Za? I'm always mispronouncing your name. Looking in the chat there. As I was saying, on demand, I wanted to blow cold air right where I sit at that bench in there, at that high wall. So, thinking I want to make it to where I could turn it on from that. But then eventually the hot water will get too hot in the water heater, storage tank, you know, the water heater is. And so I'm going to have to probably make it to where that heat exchanger, when I hook it up to this somehow, I'm going to have some solenoids or something, make it switch to where that other half of this coil, I'm going to take the 4 circuits and make 2 and 2 evaporator, and then the other 2 for the condenser. So when it has to switch to the outside to reject heat during the summer. During the winter, when I don't want cold air blowing on me, and I work in the garage in the winter, I'm going to want it to switch, you know, and reject, and you know, be absorbing heat, you know, the evaporator to be that other half out here. I think it'd be pretty cool. Might be able to do some funky stuff, might be able to make it actually function as a heat pump where it can switch things and heat, maybe heat in the garage too, because right now that Fredericks actually will heat. So this is going to be a real Frankenstein to do this, but I'll probably take my time on it. So I messed around with this circuit board and this thing, and I hooked it up with the line set I made and put a high wall, and it actually turned on and had a P4 fault over and over. Can't see anything wrong. It's the reason somebody changed it. It might have a compressor that's doing something weird. It ohms out just fine. Or it could just be a defunct board. Thinking it might be the compressor, but anyway, I can't use that for my Frankenstein. Hooking water up, heat exchanger up and stuff like that, this thing would probably wig anyway. Works off of thermistors and just very sensitive the way it monitors the current with the inverter drive and stuff. Just couldn't do it like that. So I'm going to cannibalize out that one, and after I repurpose the coils and figure out how the changeovers will work, then I would just tear that one down, probably put the compressor in there, or maybe get another compressor and put it in there. Yeah, it's just a regular, it's just a 120 volt split capacitor compressor. It works off my solar inverter just fine, running off of batteries, which it probably is right now. So I'll put that in there. So since I'm taking this board out, because that fan was running off of that board, I'm like, how am I going to run that motor if I don't change it? It is a permanent magnet DC ECM motor where the inverter chip was built onto the chip. So you got the main inverter for the compressor, and then you had this inverter chip right here for the fan. So 50 watts fan, and so I guess that's all they needed. You got to think that heat section of the heatsink was out here. Doesn't even have air going across it, but I guess motor doesn't really heat up chip that much. So I'm like, I go, you know what, I'm gonna take one of those fan inverter boards might still be good that I thought blew up in that freaking unit, so I hooked it up, put some power into it, and the fan works. I'm running this fan off the inverter board out of that unit, out of one of those units. But when the one board freaked out, I took the one from my other one, because I have 2 of those tall boys, and then it still popped my board. I thought there must be a short through this. Fuck those up. That was one of the reasons I kind of threw that project to the side. But after I got that one running, I grabbed the other board. So I have 2 of them. Should be a little more careful with that. And I swapped it, which now that's the second board I tried today, and it's working. So both those inverter boards are good. So as it sits, I only have one bad motor in this unit, and that's because I wanted to cool the house down just a little bit, so I go, man, I don't have a fan running, so I just stuck a regular small VFD right to this permanent magnet DC motor. Now I made it do that, ran way too much current, and that smoked that motor. Pretty sure it smoked. It was getting hot. It was smelling it, and it tripped the VFD and everything. So sure, it's cooked. So I'm short one motor, but I do have 2 of those units. Anyway, I'm thinking, I go, how is it shorting out that unit? I thought, I had a direct short or something, but I think I realized what's going on is, especially when I hooked this back up today, I just used one diode, so I'm halfway of rectifying the AC voltage into a DC carefully. Red and black charges these capacitors. There's no current limiting or whatever, so just these 2 450 volt capacitors, 220 microfarads times 2, so it's like 440 microfarads. Charging those up from discharge, you could hear it go pow when I plug that cable in, but it doesn't trip the breaker, and it charges up and it runs. I'm like, you know what? I think when I was it was taking the DC bus from the VFD into this when I turned it on. I think it was just too much current surge, but I don't know. I still don't explain it. It would go pow, and then it was actually tripping my 50 amp breaker. So I still at this moment have no idea how that was happening. Tripping, blowing up my little board, it was like fusing it. There was no short to metal, nothing like that. I did have it on those plastic standoffs that I bought off Amazon. Pretty sure they're not conductive. Well, I put my meter on, it didn't seem to conduct. And I don't know if maybe at some certain point that they became conductive. This is really weird how, where is the flashlight on this thing? Well, you could see it. You can just see how I popped one board then the other one. It just fused them, but these are plastic standoffs. Thus somehow it was touching close and I don't know. I still don't have an explanation. But I tried hooking up stuff with diodes externally, but I was using like fuses and it was popping the fuses. But I realized, I think it's my Lennox unit now. Oh, that kicked all, almost like it kicked up is it 7 o'clock? Probably, I think I just went up to it. Yep, 7 o'clock, so it dropped temperature from our time of peak use is over, so it went to second stage. So what was going on is it's the inrush discharging the capacitors and somehow shorting through something. So I think if I just hook that up to an external rectifier and not using the one in the VFD, because it blew up. Somehow it blew up this VFD's rectifier. This VFD doesn't power up at all no more. Tripped my 50 amp breaker. I don't know what it did, and yet all it was hooked up to this board, and these boards are fine. It's a mystery. It's a mystery, guys. Put my glass on so it's put a piece of fish paper behind the board. Well, they had the plastic standoffs with about 3/8 of an inch, and I did it to 2 boards, so I don't know. It was really weird. But I think if I ever do it again, I'm going to do external rectifier, not going through my VFD. Probably just halfway rectify it like this. I got some flat diode, 220 packages or whatever they are that look like that, the 2-pin ones. I could actually mount on a heat sink in that unit, and just what I'll do is I'll go through a current limiting resistor to start getting the capacitors charged when they're dead charged, and then have like a 2-second delay on a relay that closes, and this will already be up to like 100 volts or so before it closes, and you won't get that first pow that you get. And I'll tell you what, I know that this fucks shit up. Sorry about the F-bomb. But we have like all these Daikin units we had lots of trouble with, and their inverter boards, I know inside their fan coil units, whenever we would plug in the power, it would do that. You go pow, you plug them in, and every job that the last company I worked for that was installing those Daikins, every job they installed those on, they had 15 amp fuses, well over the rating for like little 1 and 2 ton freaking fan coils, small fan coils, man, like 12,000 BTU, 24,000 BTU, whatever, 15 amp fuses on 230 volt, 208 volt, single phase. Every job we put those split systems on, we randomly would get calls for a fault, and it's a stupid fault on Daikin. It says, oh, there's a fault on this. It's just, there's a fault in the system, just not this one. Well, what it is one unit, the power goes dead. And then eventually it shuts the whole system down. So every office or every fan coil, that whatever is on your system on that branch of condensers goes down. It's a sucky thing to happen. And anyway, I would go and check it, and it'd be a blown fuse. First I'm like, oh crap, got a short or something. Checking out everything. Can't find nothing. Motor's good. Nothing doesn't seem bad. I put a fuse in. Let's try it. Put it in. You get that pow when it charges the capacitors, but it works. And then the same job. I get like a couple weeks later. Oh, got that same alarm again. Go over there. It's another fan coil. Same thing. Can't find nothing shorted, whatever. Eventually, at multiple jobs, it's realized these fuses are like are opening up. I'm thinking maybe somebody's turning off the disconnect to change filters, and every time you power it up, or if the power goes out to the building, you get this inrush of current for charging up these capacitors if you don't do it through some sort of current limiting device, and it pops the freaking fuse, or whatever the weak link was, which is my board, was a fuse. So even though I didn't think these be a big deal, but here's the thing. Remember I was running those 2 fans in the garage? It didn't do that. But why? When I was doing it in the garage, I didn't have the 250 volts in my house feeding the unit. I was going through a step-up transformer and through a stupid that thing and all this stuff. And I think what it was is it was suppressing the surge through that step-up transformer and the extension cords and everything. And the problem did not reveal itself. It worked fine, and I put like a dummy motor where the compressor would be, and I had that whole unit running off my controller. It was awesome. And I come out here, pipe it to my house, and then when I go to hook up the disconnect, put the disconnect, boom! I mean, turn the breaker on, scared the shit out of me, like sparks came out even. Like, what was that board? Little board. It was acting like a fuse. So, weird. Why you know what? I think I answered the question. I think, you know how a plasma, when you use a plasma, anybody uses a plasma torch? I think I figured it out as we're talking. That's how this works. When you use a plasma, once you get the arc going, you could back off your cutting tip of your plasma torch from the metal surface and have a gap like this, even out like this, and it will keep cutting because the superheated plasma somehow it like conducts your electricity through it. That's what happened when it's the inrush of the capacitors. Pop makes a flash when the copper goes, and then the plasma continued the current through the plasma to my metal here, through that 1/4 inch, 3/8 inch gap right here of the standoffs. There's standoffs on here. That's what it did. It flowed through the plasma arc, and then it pulled a lot of current. You see how that is? That's not, I mean, that little thin circuit board wouldn't have done all that from popping. It frickin' for like probably milliseconds until ramped up in the current flow and tripped my breaker and blew up my fucking VFD. That was because it was on the DC side. It's DC direct current when it did that plasma. Holy shit, figured it out. That's what it was. There never was a short in anything that I built. It was just the freaking popping of my little circuit board. In fact, if I would have probably had a direct connection from this red and black wire to my VFD, and I went through my little circuit board to my VFD, it never would have done that. My unit would have worked. I guarantee it. I just pretty sure it's what it was. See, fish paper. No shit, huh? Well, it would have popped my boards anyway. So I need to make a new interface board that just connects to here to here. And what my interface board did was a disconnect passed through the DC. I had I-loop connectors from the VFD's bus to my little circuit board, and then I had the 5-pin plug for this to plug in there. So it passed through the 330 volt DC to this, and then it just had your 15 volt DC going through an optical isolator back to the inputs. It's taking its own power supply, pulse width modulation to regulate a DC in. I'm just doing it with resistors right now to make the fan run. And then I had pulse width modulation going into my optical isolator from my microprocessor. That all worked. Good thing I used an optical isolator, huh, guys? Because I'm surprised that arc didn't actually carry back all the way to my freaking board. Or did it? Did it fry stuff? Now I can't remember. I did have to fix some things. Anyway, what I need to do is make a new improved interface board. Maybe make the traces a little heavier, but what I need to do is I have to order some big, hefty, 5-watt resistor or something, or take it out of something, and have it with a diode charge up this capacitor, and make it wait like 2 seconds, 3 seconds before the relay closes. And this fan doesn't need to run immediately, or the fans, they can wait probably a couple seconds. So have it just wait a couple seconds before it closes the relay, and these capacitors are already mostly charged, probably through the resistor, and it will keep it from popping my trace, which will keep it from making plasma arc, which will keep it from sourcing through the plasma and shorting out everything in its wake. Wow, doing this live stream, I actually freaking solved it. The clearance. And you know what, GN, I have a whole standoff kit, so since we're talking about it, you know what, if I try it again, I'm going to put like 1-inch standoffs in there. But I'm also just going to go ahead and just run a separate rectifier diodes from the power into this, and not take it off the VFD, because I toasted one of my VFDs I had because that thing shorted in the plasma. I had it off the DC bus of this thing, and it freaking took it out. So that sucks, huh? Oh, anyway, like I said before I started the live stream, but some of you guys want to know, is when I first was fucking around with this today, I actually didn't hook up the 250 volt I say 250 because that's like what my house has pretty much feeding it a lot. 246. Like my voltage is high here. 246, 247, yeah. So it's about almost 250, man. And but earlier I took 120 volts through the diode and to see if this would run off 120, because this, when they tell you to check these for high voltage, it gives you like a 100 volt span. That's okay. So I basically under voltaged it a little bit with the 120 that I rectified. So you might have like 170 or 180. And it ran. It actually ran the fan. And the reason I want to test that is because if I use this as a Frankenstein for my water heater heat pump / dual mode for cooling my garage, I need to run this fan. And I could have changed the fan to where I had the chip built in, and then all I have to do is just send the, power it. It's the same connection as this actually. It's just that this logic and everything and driver is inside the motor. But I don't want to have to buy a motor. So I could temporarily probably use this board since both are working, and I can still get the other one running. And I know it'll work off 120, put my 120 volt compressor in there. It's probably gonna take me a couple months to do it because we have so much going on. We have, like, on weekends we go, sometimes we're going on trips with K&M. Macy always wants me to take her. Man, I've been neglecting doing that lately, so I'm gonna have to get back to that. So it'll be a slow thing. So I might continue on the heat pump thing first, just so I could get the get the AC in my garage running off of the solar. And then, plus I think I already said, hey, I'm not going to screw with the AC units until after summer. So I have till the end of summer to get that unit working again. Just cooled down to thermostat down to the drop at the first stage. You can hear the compressor when it's on 40 hertz, but it sounds normal when it's on 60. It's kind of funny. Anyway, sun's starting to go down on me now. So hopefully the video's been okay. I'm on the downstairs Wi-Fi. Nobody said anything that it sucked, so I guess I'm good. But anyway, I figured out some stuff. I figured out how I can make this unit work. I figured out that I didn't blow up the inverter boards, which maybe make my gear spin. And talking to you guys, I've fixed stuff a couple times doing that. Whenever, or just want to make video recordings. If I narrate, it makes me explain how a circuit works, and you figure shit out. And we figured it out. It was a plasma generated just from popping that stupid Amazon copper on those little circuit boards I was etching. That's what it was. That is funny. Let's go see before I end the video. Go see if I kept any of those circuits, or did I throw it in here? There's that. This is pigtails I cut off some other motors. I'm going to have to put these back on. This is kind of my scrap bin for all the VRF stuff. Let's see if I threw that. There's one of them. Okay. So here's my little boards that I had in there. And what this did was I had just red and black connected on here. You can see it smoked it. Just going up with 2 eye loops coming off my VFD's DC bus. It came here and just passed them through these 2 pins. Red and black right here. This would plug in just like this, pass through the high voltage, and then I just had the optical isolator, with the pulse width modulation in, going through the resistors and through there, and then just sending in a DC to the speed command signal. It all worked in the garage. It was just when it got that inrush current, when it was popping these traces right here, and you could see the only traces that are fried are the ones that are in series with the DC bus coming in and leaving out to this. That's all it was. If I would have probably just drilled these 2 holes right here and had them so next to each other where they would have been soldered directly connecting them, it wouldn't have probably done that. It would have worked. It would have been working. It's just that this thin copper popped from the inrush current for the capacitors. It made plasma, and the avalanche basically effect of current through plasma. Isn't that weird? If you guys ever watch those videos, you always wonder, how does that happen on switchgear and stuff? You make enough of an arc from the source to ground, it will fucking flow current, man. Like a lot, and then it runs away. It goes as much as the circuit can handle until something blows up or whatever. So yeah, Wow, that's gonna be quite the story. 720 is like 240 resolution on my end. Oh, and you're just saying, Nate, here your connection's bad on your end, not necessarily how this is going out. It's still running the fan, so I'm gonna have to probably call this in a second. It's darker than it looks. The camera's doing a pretty decent job at light gain. Yeah, how about that? So, all right, I'm gonna start wrapping up. And you know what, guys? I mean, I definitely got my life out of these Testos. This one kind of got snapped a little bit. I got to tape it back together. You know, and after these buttons started falling off, I taped up like this, so I had to push through the tape to turn it on like that. I actually liked it better than original. Or get new ones, and I was to keep these like in a pouch or whatever. I hate how they would get turned on accidentally. I would probably almost rip the rubber off and wrap them with tape, because you have to put your finger in there to hit the button now. Anyway, they are still working, man. I've only lost one Testo instrument, and that was one of the clamp-on pipe clamp temperature probes. So you can see good now. So yep. All right, it's getting dark pretty fast. I got to wrap up. So okay, guys. Well, Frankenstein projects. This will be what I'll probably be working on over the next through the summer, and then after summer, he lives. This bastard right here might see another day. Yeah. Dang. And you know what? I had it piped in. I was starting to put the refrigerant, which I just transferred from the one unit to the other. It was actually working. I never did get to, you know, leave it running, but it was like the pressures were looking pretty normal. So I think my repipe actually worked on that condenser. But wait till after the summer before I do that again. So, all right. It's way darker than it looks. The sun's actually to where you can't even see it, so I gotta put this stuff up. I'll catch you guys later, man. Don't forget to like and subscribe. All you guys have subscribed though, but all the bastards that watch it later, like and subscribe, you know. And maybe next time I'll be recording when something blows up to that. That's that spectacular, because it actually. I'm used to stuff blowing up around me. You know, if everybody's seen that electro boom guy, how he started out was just by blowing stuff up and acting scared. I'd be like, oh, I just laugh. Dude, that scared the shite out of me. And then, like I said, it blew my 50 amp breaker, and I tripped it every time in my house. So that's pretty, you know, that plasma arc was pretty awesome. So, all right. Catch you guys later.